Cool. So this is going to be mechanical workshop number 1, in case we need to have another one. Next slide. So the components of pretty much like the building the robot is going to be the chassis and drivetrain, and then the subsystems, which are normally intake, shooting, lifting, and then we also have arms added in later, and then the electrical system.
This is also excluding like the design process because I don't know how much there is to teach about the design process, but also anything that we don't cover in depth is going to be in our handbook.
Yes. So the drivetrain, so when building the chassis, if y'all decide to use a chassis kit, which I would, because I think me and Caitlin had talked about this, maybe some of y'all were part of the conversation, can't really remember, but you know, like you kind of want to use the chassis kit for a couple years once we build up our resources and knowledge and material wise, and also the budget, because it can be pretty costly to like build your own chassis from scratch. And also, if you don't do the chassis kit, make sure whoever's in charge of like the what's it called, like the kit of parts, puts that in there so we can get more money for our first choice. But the chassis kit includes like 3 different ways of building the chassis, which are square, long, and wide. Normally it just depends on like what the robot design is, but the long and wide ones are probably really good if you're going to keep a shorter robot, and the square one or otherwise is like for a more tall one. And then there's a different kind of wheels you can use. So the caster wheels, which are normally, like you'll see the thinner ones like on shopping carts, but normally you want to use the caster wheels for like shooting mechanisms, which we'll talk about later. There's also pneumatic wheels, which we used in our first year robot. They're pretty good for that year. They were pretty good, I guess. We didn't really pick for pneumatic wheels, but they worked because we were going off of a platform, so we wanted to make sure that there was a bit of room for the robot to kind of have some give if once it hit the ground really hard. There's also holonomic wheels, which are like a type of wheel. So you can either use omnidirectional or mecanum. The mecanum wheels are pretty selective though, because you have to use a mecanum drive system, which is pretty hard to build and it's very specific. So that's like something that like the big teams use. But like this year we use the omnidirectional wheels in addition to our 6-wheel drivetrain because they helped with like better mobility and turning. And then we also have compliant wheels, which are normally used for intake, kind of like we did this year. We used them in addition with our convex wheels that we 3D printed, and that ended up really good too. Next.
Oh, something I just wanted to add is that if you want to not use the chassis kit and you're going to do like a custom chassis, or if there's like a very specific drivetrain that you're thinking of doing, you do have to kind of plan in advance, or you have to have it built ahead of time if you want to have the option of even using it during season, which can be difficult, like since you wouldn't know what the game is yet. So it's definitely one of those things that makes a lot more sense to start thinking about once the team has a lot more experience, because you have to have those resources to kind of be willing to like build a chassis that you might not even use.
Yeah. So subsystems, and then just a little disclaimer for a lot of this information, you know, a lot of this is from our own experience and research. So, I definitely forgot to keep typing this. Sorry about that. I'll go and fix it. But when you are doing like your design process, you know, still don't just limit yourself to like what we've done in the past or what I include in here. You know, you should always be thinking outside the box and thinking how you can use people's previous experiences, using the best parts of those while overcoming the limitations that they found. So you just want to continuously be learning from the past, and so that's kind of why we do this too. So I'll let Caitlin do the intake.
So feeding systems or intake systems are the subsystem that like brings things into the robot. So this is applicable in like almost, I want to say almost every FRC game so far is there's like something that you have to pick up or bring in so that you can like shoot it or place it somewhere else. So for example, on our first robot, we had an intake for the hatch panels, and then this past year we had an intake for the fuel. Is that what we called it? Fuel? I'm getting my games mixed up. But so usually it'll involve some sort of wheel, either wheels or bands. So this past year we used a combination of both. Um, and this can either, so if you're like having a floor pickup, for example, something you have to think about is if you need to have like a cutout in the chassis, or another option is to have your whole intake system like move out using a pneumatic system. Again, like Cassidy said, these are just like some of your options, but there are a lot of really creative intakes or feeder systems out there that use like completely different principles but still work really well. You know, like you don't necessarily need to like find some way to get around the chassis, and so this is where like studying different robots comes in handy. One key thing that kind of does apply to all intake systems is thinking about compression and speed, and like how what you're building it gets like the whatever you're trying to bring into the robot, how it does that, and if that's the best option. So for example, like you could have like rollers or a band, or like even like dual sets of wheels on either side, and all of those options are like good for different things. So this is where the design and research process really comes in.
Yeah, so then, oh,
Is it? Yeah.
oh wow,
Which
sorry, I thought
slides
I
do
saw
you
something
want?
else. We can do this one.
Okay.
So for shooting, when I did my research, like for this year, I kind of found these two different ones. So you can use like some teams will use catapults, which are good if you just have a low number of game pieces because they're a lot slower in having to reload. And there's a couple different ways of doing it. You can do pneumatics, but kind of like the main thing for this is you need a working pressure tank that will like slowly fill the piston without fully extending it, because sometimes if you don't have that, your piston will extend really slow and not like fast with a lot of pressure, which is essentially what this mechanism would need to actually catapult something through the air. They also have spring-loaded catapults, which they call like either cam or choo-choo. The cam one kind of looks like a shell shape, and so it's kind of like that. I don't know. They're both really interesting if you do want to look into them. You don't really see these as commonly, but yeah. And then they also have a motor-driven one, which is good if you're not going too far, but they're also not very powerful. So, of course, all of these have pros and cons. And then they have also wheeled shooters, which is like what we did, because it's really good for a large number of projectiles in a much quicker time frame. But you also need to make sure you use a heavy wheel, such as the caster wheel, which we talked about earlier, mainly because this really helps increase the inertia of the wheel itself. So when the ball does, or when the wheel catches the ball, it's able to fly out much faster and further with much more force, without trying to increase your motor to a super high speed. Because this is pretty much where we went wrong, at least this year. So in our first competition, obviously we had difficulties, finding the perfect in between what kind of motor we were going to use, how fast it was going to go, etc. And we were talking to some of the other teams, and one of the mentors brought up using caster wheels because it is really heavy. So it does the same. It, like I said, it increases the inertia and makes it much better. And then for lifting, so this year was like our first experience doing any kind of lifting, and a lot of times elevators are really reliable if they're done properly, because the rails have to be perfectly square for your carriage to move really smoothly, and they're also pretty heavy, and they're kind of a waste of space if you only do one stage. But a two-stage elevator is like a lot harder to design and build for the first time. So if y'all are looking into doing that, make sure you start early, like we talked about, with like other drive systems too. But with this two-step elevator, you really want to make sure you start early. And I would really recommend reaching out to bigger teams for tips and tricks. And they might also have the different parts that you need. So yeah, definitely. There's other ways of lifting, such as using continuous cabling and like a rack and piston pinning, which are pretty interesting if you also want to look into that. I kind of further expand on it when I talk about like different arm mechanisms, but yeah.
So same thing with the different types of drivetrains. I would say that with elevators, like the Radicubs has never successfully built one before, and then even my old team, which was like had been around for a really long time, had like really limited experience with elevators. They definitely are a thing that you like in games that require elevators. Like almost every robot will have an elevator when it's like a height-based game. So for example, Power Up was that way. But it's also one of those things where like if you don't need to have an elevator, there's kind of no good reason to have one. I like with the different drivetrains, as I was saying, I would definitely recommend building this like in preseason just to learn how to build an elevator, because like this past year, like we've experienced with some of the times we're trying new things, it's kind of not worth it, or like it would just not be the greatest situation to be in the middle of build season trying to get this elevator to work when you really do need it. Like we were lucky enough this year that we got away without having an elevator, but if you needed one and you were in build season, you're trying to build it, it didn't work, that would be like a really awful situation.
And so for the arms, like we've done very limited, you could say, arms. Our first year, like Caitlin talked, it was kind of like a more of a feeder mechanism than an arm. It did extend. We used a piston to kind of extend it out on a very modified horizontal elevator system. It's really interesting. If you do go look at it, I'm a little proud of it because it is pretty interesting how we were able to manipulate the original elevator design. But yeah, so for extending, a lot of people will use like cables or belts, a rack and pinion, or a lead screw, which these are all very interesting things. I'm definitely right now in off season before next year continuously doing research. So I don't know if captains, this is something you want to do in future meetings, but going through different systems like this, everyone does like little research things. They find something that's really interesting. I think that actually could have helped us a lot if people were like definitely like passionate too about trying to find new things, because they're super interesting like when you look them up. But sorry, a little bit of tangent. So the cables and belts are lightweight and they're really good for multi-stage arms. The rack and pinion mechanisms are heavy, which is also like when you use it, if you use it for a lift system, it's pretty similar, like they're really heavy, but they are precise. And then the lead screws are precise, but they're still slow. And then rotating wise, they will definitely rotate around one axis or axis. I can't talk. They're driven with a pneumatic cylinder or a reduced motor. And a lot of people to counteract gravity, because depending on what you're picking up, it can become really, really heavy. And then sometimes I think we've even seen robots will kind of get off balance and then they like end up falling over, which is never good. People use, I definitely spelled that wrong, a spring. They will add a spring to the arm so it can move more freely and essentially be like almost lightweight. So electrical wise, this is a lot.
Wait, sorry, I didn't
Oh,
realize that was the last. Can I like add one more thing about building before we get into electrical?
oh, for sure, yeah.
So what I was gonna add is just to be like very frank, due to like the purposes of these workshops, I'm just gonna say that like nobody on, okay, so like going into this last season, we barely had any building experience, and then I'd say like nobody on Radicubs now really has like a lot of mechanical experience. And because of that, I know like that the Radicubs is going into its third year and stuff, or like, you know, like the next couple of years, because we don't know what this upcoming year is going to look like. But I do think that it's just really beneficial in general to learn how to build like high quality basic robots before you get into anything too complicated. Because even with arms and elevators, like with like our limited mech experience, and I guess like the like graduated group of us, or mech wise, like me and Cassidy, with our limited mech experience, like we had a really difficult time building like even just the static structures on the robot because of how much precision is required. um, so just take that into consideration, because it's really easy to look at what is possible to build in theory and identifying like what would be objectively good solutions, but kind of skipping the fact, and this isn't like a snub on anybody like the team at all, it's just like it's so easy as anybody who's like building something to forget the fact that like in the end you still have to physically build it like with your hands and with a ruler. And that's just like such a limiting factor, unfortunately. So just like I honestly, like with all of the theoretical stuff, like that's great, but I feel like that's like the most important thing that you need to remember when you're designing, because there's always like the limit of creativity and then the practical limit of building things. Okay.
Yes, definitely good point, Caitlin. That is a really good point. Everything you do, you just need to make sure it's very practical and achievable. Because if you set your design to be something super complicated, it's not rewarding at all when in the end you do something that isn't that big dream you hoped for. So, at least in my opinion, it's always good, start small, achieve what you can, and then build from there, because you have to start somewhere. So onto electrical. This is almost pretty much the same every year. Like we used almost the exact same electrical board that we used the first year as last year. It's what powers the robot, and it's kind of, as most people say, the nervous system and brains to the robot. So your components are going to be the Robo Rio, which is what directly connects to the computer that's sending it information, whether that's the original code that gets pushed, or from the driver and the button system working together. The Robo Rio is also what then will send that information everywhere else throughout the robot, whether it's the motor controllers, the pneumatic control module, the PDP, all that kind of stuff. The PCM, or pneumatic control module, is what you'll use if you do end up using pneumatics. It's not required, so like this year we didn't have it. But yeah, it's pretty much how you will control the solenoids, which then controls the pistons. And yeah, it's pretty much, if you use pneumatics, it's necessary. The CAN bus, which are these green and yellow cables that connect almost everything that gets information. I'll really explain CAN bus versus PWM cables kind of next. As you can see, they're kind of complicated. The VRM is the voltage regulator module, and so it's kind of what goes in between normally the Robo Rio and the router, I think. Maybe not, I don't know, it's somewhere in there. On the next slide, we're gonna look at the whole way you put it all together, but yeah, it's just like a regulation thing. And then the PDP is what you connect the battery to, and then it connects to pretty much everything else, whether it first connects to the Robo Rio or all of the motor controllers connect to it individually. And it's also, if you use different sensors or different add-ons like the limelight, those kinds of things, they will have to end up being connected to the PDP. That's how it gets power. The robot light, necessary. It's more of a safety precautions, because when you are playing on the field, it's a really easy visual signal to see, obviously, if the robot is on, if it's moving, and at the end of the game, they're able to turn it off really quickly, and just make sure that your robot's just not going to move anymore. I don't know, kind of disconnected. And then the main breaker, another safety precaution, which is absolutely necessary in my opinion, to go in between your battery and the Robo Rio. You kind of make a mini circuit throughout the three. And so yeah, it's just so that way nothing goes bad. The battery, you're gonna need a lot of batteries, as a lot of y'all saw if you were there. You're constantly wanting to change batteries because you want a full powered battery. We kind of got in trouble with this a couple times our first year of using batteries that weren't fully charged, and it kind of makes your whole robot stop moving. Yeah. And then motor controllers, this is what goes in between the physical motors that you connect to subsystems and the PDP and the RoboRio. So now to go into CAN bus versus PWM. So for the last 2 years, we've been using a CAN bus, and it makes a circuit from the RoboRio, the motor controllers, the PCM, if you have one, the PDP, and then back to the RoboRio. And so basically what this is for is it's not to send power, it's to send information. So the reason why it pretty much only goes to motor controllers and the other things is because the motor controllers are what you tell like certain values to. And so this also connects pretty heavily with coding. It connects, it's like how you get information to the motor controllers to tell them how much to rotate, how much value to give. And in my opinion, it's much simpler because it uses way less cabling. You just kind of make a big circle with the cables. But then PWM, you will need to, there's a whole section on the RoboRio that's just for PWM wires, and it's just another way of sending information. And pretty much the only things that will use these are the Talon motor controllers. They'll most of the time use PWM, or if you use servo motors, sometimes they'll use PWM. So some years later down the line, if y'all do move on to those different motors and equipment, you might have to have a combination of both, but the PWM is a little harder to wire because you have to wire it directly from the RoboRio to the individual motor controllers every single time. There's not that same circuit you can build throughout all of your motor controllers and stuff.
So just to clarify, like it's not like every electrical board will require both a CAN bus and PWM wiring. I tend to associate PWM along with all of the rest of the red and black wires. And so basically that's just like, I don't know, like you could think, if you're thinking of anatomy, like you could think of one as like the skeletal system and one is like the muscular system or something like that. But also, if you guys know anything about circuits, basically the CAN bus is just in series, and then the PWM connects all of the things that need to be connected directly. And you don't have to memorize it. There are very clear guides about these things online. We'll definitely find like the main like I think like First has published a like how to wire your electrical board thing. We'll include that in the handbook and stuff. But yeah, and you can also find diagrams online that make it, there's one on the next slide that make it really clear like what needs to be connected to what and how.
Yeah.
So Cassidy included an approximate build timeline based off of what Rana and Ishan planned this past year, and it's just something to like keep in mind throughout season.
Yeah, pretty much. A lot of it, like you'll see, like we've talked about before, you kind of want to start a little bit, not necessarily planning for exactly what the robot's going to be or designing because you have no idea what the game's going to be, but kind of start planning for who knows how to do what and learning more resources. Sorry if you hear my dogs barking. Actually, let me go let them in and I'll let Caitlin talk some more.
The main thing that I would keep in mind, or like that I've tried to keep in mind these like the past 2 seasons, is that basically by the time you hit season, there shouldn't be anything left to do that you could have done pre-season. Again, we don't know what it's going to look like this year, but just as much as possible, like if you can prepare for something all the way down to like making sure that everybody knows how to use all of the tools, and that like you know what like timeline for your design that you want to use. Literally every scrap of work that you could do before season and that doesn't require knowing the game, I would do.
Yeah, even little things like buying acrylic and buying sheet metal and making sure you have a lot of aluminum, like those things are super important because like as y'all probably know, last year, like there's always like setbacks where it's like, oh, well, we don't have enough aluminum to do something right now. Like we're still waiting on it, or we still need to go get this. So the things that like you always know are going to be on the robot, you may as well do those and get those things ahead of time.
Yeah, like all of you have experienced a season now, so especially for anybody who's involved in mech, like if you remember something that seemed like it took a really long time, or there was something that like was like, oh, like that was a trip to the store that we really could have made earlier, just like all of those things, you know, if you just like think back on last year, like that'll help you prepare for like upcoming seasons and stuff.
Yeah. So yeah, do y'all have any questions? Oh, here are two sources that I actually used a lot last year. The one that's like the Chief Delphi, it's actually super good. It's, if you look at it, it's called like Total Guide for Noobs, but it is super good. It has so much information. Same with the one above. It does a lot more in-depth about subsystems and just like build season and like the design process too, which will include in the handbook because it's always kind of different. And maybe in another workshop if that's something y'all want and are interested in. But yeah, so if y'all have any questions.
So yeah, I think I have a question. So Cassidy, do you remember how you guys configured the CAN bus? Like, so if we were to, you know, like try to add another device onto that CAN bus, how exactly would we go about like, you know, configuring it to, you know, communicate with that other device?
Yeah, so
oh, do you mean on the coding end or just in terms of like actually putting it into the CAN bus?
Both. Do you guys like, I don't know if you guys know, but do you remember anything about how we would configure it on the programming side too?
So my understanding is basically, so you like insert it into the CAN bus in series, and then once you've connected it, you're able to see it on the programming end, the way you're able to see like the motor controllers and stuff that are already there.
Okay.
Yeah, so me and Samara actually did work on this together because this year we added 2, maybe 4, I actually can't remember, but we added more motor controllers. So physically it's very easy. You can either cut the CAN bus apart, just like cutting the wires, or you can, cutting the wires is probably easiest, and then soldering the wires together with the new motor controllers in the circuit. It's really easy. Each motor controller has like a yellow and a green, and then has like 2 sets of yellow and green wires that like go in 2 separate ways. And so you'll kind of put those into the circuit, and you just connect the ones that are physically next to each other together. And but then programming wise, I know me and Salma really sat down and we had to like reset and like do certain things to the motor controllers, like physically having to push a button in. And I think Samrat can talk more about how that looked from his side on the computer.
Yeah, so there's like a program called, I think, Phoenix Tuner, and once like everything is connected in the circuit, you'll actually be able to see like each of like the CAN buses, and you can just configure it that way. So you can like update those or do whatever you need to do with those. It'll also give you like the values and stuff for that. So if you need to communicate with that, you'll have the value for that, which you can use on the code.
Okay, that makes sense. All right. So yeah, that answers my question. So I know that me and Samra actually used Phoenix Tuner to get the values, which we put into our code. There's a separate file for the constants. Anyways, this is good for documentation.
Cool. Any other questions?
If like maybe what people are thinking of questions, but one thing that I want to add it's not necessarily related to mech, but it's like beneficial for the mech team on the Radicubs because we don't have any like mentors who are familiar with FRC mech specifically, because there are like a lot of very like FRC specific things, is that Chief Delphi, at least on our team, is a completely underrated resource. like I think there were 2 times at least when we got very, very stuck on mech and we were doing all this research and we couldn't figure out what the best solution would be. And I just made a post on Chief Delphi, and like by the next day we had all of these people telling us like what our best options would be or like how to solve our problem. So definitely like looking at other people's postings there and making your own postings. People look at them so fast because everyone's just on the forum and stuff like that.
If you don't want to use Chief Delphi, there's also like an FRC Discord server, and you'll get answers there like instantly, basically. And their answers are really good. So yeah, Chief Delphi or the Discord server, they're both really good.
Yeah, and if y'all do have any questions, I think just let Selma and Anant know, and they can send them to us. I know I will not be here this first semester of school and stuff, but I do know Caitlin will, so if y'all need any help, not to offer her services, but I do think she talked about she would be willing to help if y'all needed. But yeah, I won't be here, so if y'all just want to like shoot me a text or something, I'll always be welcome to help.
Also, I think like every single one of you has my phone number. So like
Yeah.
really, if you like want to ask about anything, we're here.
Yes.
Or you can just DM them on Slack.
Yes.
I guess.